I was wondering if you used all the water on planet Earth, what is the largest water balloon that you could make? So if you took all the water out of the oceans, how big of a water balloon could you make? And so I've drawn the size of the water balloon. It's about this big. Here's the USA in the background, and here's the water balloon. It's about 852 miles in diameter. And so you say, well, how do you come up with something like that? This shows you the relative size. If I just say 852 miles in diameter, maybe it's a little hard to picture that, but here it is. It covers up a good chunk of the USA. And here. Now, of course, this thing would actually be in 3D. It would be a 3D sphere, a water balloon, but I don't know how to do that on Google Earth. It just lets you like draw a little perimeter around. So imagine this as a 3D water balloon splashing on the United States. Cause a big problem. But this is supposed to be a 3D, so this would be like a slice through the center of the water balloon. And I use this little distance thing to show you this is about 852 miles. Now, how do you come up with something like that? Well, you should know this number, memorize this number. The circumference of the Earth is about 25,000 miles around the equator. And you should also know the relationship between the circumference and the radius. So the circumference equals 2 pi r. So if you invert that and solve for the radius, you just divide the circumference by 2 pi to get the radius. And so the surface area of the Earth, maybe you know this, the surface area of a sphere is 4 pi r squared. And this is probably good to know this, that about 71% of the planet is covered with ocean. So the surface area, 71% of the surface area of the Earth is water. Now, I didn't know this. I had to look this up. What is the average ocean depth? Pretty deep, 2.3 miles, really deep. 12,000 feet is the average ocean depth. Okay, fine. So ignoring curvature and stuff, 2.3 miles out of 25,000 miles, we can ignore curvature. And instead of like subtracting spherical shells or something, we'll just do a planar approximation, if that means anything to you. So the volume of all the water on the planet is the surface area of the water times the average ocean depth. And then maybe you know the formula for the volume of a sphere. The volume equals 4/3 pi r cubed, but you can invert that and solve for the radius. You just take the cube root of the thing with some constants in there, and then multiply by 2 to get the diameter. So this is all like very approximate. So the thing is about 850 miles in diameter. So what is 850 miles? This is our water balloon. So if you look at the planet, you take all the water off all the oceans, and it makes if we made this a sphere. Now this is drawing it is just like a pond. It's not that it's like a pond, it's really a sphere. You have to think of this as a sphere. Use your imagination to imagine this thing as a sphere that has depth to it. This is what it would look like cutting through the middle of it. And so this is the size of the largest water balloon you could make. Maybe you thought you could make a water balloon the same size as the planet, but nope. The planet's it only has like a skin of water over it. It's like rock and iron and molten stuff in the center. So that's the largest water balloon you could ever possibly hope to make. And I hope that was an important question that you were really wondering about, and now you know the answer. Thank you very much, and have a good day and a good week. And don't stop there. Have a good month. And thank you very much.